Hey guys, so right now what we're going to do is we're going to be factoring completely these next four examples by grouping. It's a four-term polynomial that does not have any greatest common factors between all four terms, or it's neither dots either. So your first step is to group the first two together and then group your second two together and find the GCF of each of those terms. So the GCF between x cubed and 2x squared is going to be x squared. What do they have in common? They have two x's. Again, x cubed is really x times x times x. X squared is x times x. So you group them up. You could only group two x's together, so that would mean it's x squared. You could also look at the smallest exponent of each of those two terms, and there's no number in common. So we all know that the GCF of the first two terms is x to the second power. Now we look to the 9x and to the 27. Now they don't have an x in common, but there is a number in common. So you might want to use the GCD function in your calculator to find that. The GCD between, or greatest common factor between 9 and 27 would be 9. So the next step would be divide out your GCFs, because that's how we factor. We're going to factor each grouping by GCF. And we take out that greatest common factor of x squared. We put it in front of a set of parentheses. And when we divide x cubed by x squared, we're left with 1x. When we divide 3x squared by x squared, we're left with 3. Pause the video and make sure you get this down. Now we're going to divide out the GCF here for each of those two terms. That's a positive 9x. I'm sorry, positive 9. So you want to make sure you put that 9 there. And then when you divide 9x by 9, you're left with x. When you divide 27 by 9, you're left with a positive 3. So those signs are really important to keep as well. Last step is to find the GCF. This is considered our GCF. That GCF goes outside a set of parentheses. There's our set of parentheses. So we bring our GCF outside the set of parentheses, and then we're going to just write our leftover factor inside, which is x squared plus 9. So that's how we factor by grouping. Remember, this big x plus 3 in both of the two common is our common factor. So that comes out front, and then whatever's left over goes on the inside. Okay, let's try the next one. On to the next one. So now we're going to look to see what they have in common. So we group our two terms together. Okay, now this time we're grouping this minus sign in there. So this is going to be very important. You have a leading negative, that GCF has to be negative. All right, so let's find the GCF between the first two terms. The GCF between 2xy and 7x is going to be x. They both have an x in common. And now we're going to find the GCF for 8y and 28. GCF between 8y and 28. So we're going to have to plug that in your calculator. 8 and 28, and you should get 4. However, it's going to be a negative 4. Remember we said if it's a leading negative, it has to be negative. So my GCF for the second two is negative 4, and the first two is x. So that just means we're going to factor out x from the first two, which means I divide it out, and I'm left with x. And then on the inside, we're left with the 2 and the y. And then when I factor out x from the second two terms, I'm just left with 7. Now in this one, we're going to divide out negative 4 from each of my terms. So negative 8 divided by negative 4 is going to be positive 2y. And then when I take my calculator and I divide 28 by negative 4, I'm left with negative 7. So last step is you're going to take these two factors, remember? And then you're just going to factor out, or group out, sorry. Went a little too crazy there. You're going to just take those two factors, the 2y minus 7s, bring that out, and then what's left over goes in the second set of parentheses, x minus 4. So this final answer, because that looks really sloppy, is 2y minus 7 times x minus 4. Okay, pause the video and get this down. Moving on to the next one. Now here it's going to be a little bit more challenging because there's a little bit we have to remember from GCF factoring before. Here we have our two terms that we're going to group together. The GCF between 4xy and y is going to be our y's. So our GCF is y. And then here between negative 12 and 3, it's got to be negative because of the leading negative term. But what number goes into both 12 and 3? That would be 3. So my GCF would be negative 3 for the second two and y for the first two. So I'm going to divide out y from each of these terms. I'm going to put that in front a set of parentheses. Now 4xy divided by y, the y's cancel out. I'm left with 4x. Bring down your minus sign. Now what happens when you cancel out something or you divide something by itself? You have to remember you're left with a factor of 1. You got to keep that there. So then on to the next one, we're going to divide each one out by negative 3. And that negative 3 goes on the outside. And now I'm going to divide negative 12 by negative 3. And I get positive 4, and the x stays. And now in my calculator, I'm going to put positive 3 divided by negative 1, and you should get negative 1. So now our last step is we have our matching factor, the 4x minus 1. That comes on the outside. And then we're going to put the leftover factors inside another set of parentheses, which is y minus 3. So those would be the two binomials that multiply to give you 4xy minus y minus 12x plus 3. Pause the video, make sure you get that copy down. On to the last question. Now this one's going to be a little bit more challenging because we're actually going to have to factor it completely, which means we're going to have to do 2 steps of factoring. So your first step is still going to be factor by grouping. Okay, GCF between x cubed and 5x squared is going to be x squared. And the GCF between negative 25 and negative 125 is going to be negative 25. So those are our GCFs. All right, so now we're going to divide out our GCFs from each of the terms. So we divide out x squared. We're left with x squared times x plus 5. Now in the second one, I'm going to divide out negative 25 from both terms. And I have negative 25 times x plus 5 when I put it in my calculator. Last step, we group it. This x plus 5 comes out in front. And then inside the next set of parentheses, I'm going to put my x squared minus 25. Now this is where the trickiness happens. Many of you are going to stop here, but this is where the factoring gurus are going to take it one more step, and you have to because it says you have to completely factor it. If you notice, this term left here is a difference of 2 perfect squares. So it was hidden up there, but you couldn't see it until you factored it. So what does that mean? I have to factor this one step further. So what I'm going to do is this x plus 5 stays. Now what I'm going to do is I'm going to factor this. To factor a difference of 2 perfect squares, you have to put your double bubble. You put your plus and your minus sign. And then you square root the x squared, you get x. And then you square root your 25 and you get 5. So that's your final answer, all of that. Now if you want to be fancy, I'm just going to write it neatly just so you guys can see. You get x plus 5 times x plus 5 times x minus 5. Now the fancy people are going to notice that that is this something times by itself, which is something squared. So if you really want to get fancy, you're going to put x plus 5 squared times x minus 5. So this is where when you get into the higher level questions, you're going to have to remember to take it that one step further. Okay? So again, email me or text me if you have any questions, and good luck on the Delta Math.